What would it be like to live your entire life in a spacesuit, separated from the world by a barrier of cloth and plastic? David has lived his entire life in a sterile room, or in this special suit, isolated from the millions of germs that we encounter every day. The air he breathes, the food he eats, everything he touches must be sterilized because David's body has no way of fighting disease. His spacesuit is a life-saving barrier, protecting him from the dangerous world of germs outside. Fortunately, most of us don't need this kind of isolation because our bodies have immunity, the inborn ability to resist harmful germs. Even before birth, the body begins to develop the capacity to fight diseases. Throughout life, we are exposed to a great variety of germs that can make us sick. With a microscope, we can see many of these germs. Bacteria are one type of germ that cause disease. These bacteria live in the human intestinal tract. Under some conditions, they can make us sick. Other kinds of germs include microscopic animals such as this parasite. Certain fungi or molds can also make us sick. To see other kinds of germs, we use an electron microscope. This microscope can magnify objects hundreds of thousands of times, making it possible to see extremely small germs called viruses. Viruses can only reproduce and grow within living cells. These viruses, magnified 150,000 times, are responsible for the crippling disease polio. This virus causes measles. This is one of the many forms of the virus that causes flu or influenza. We are constantly in contact with germs, in the air around us, and in the food we eat and water we drink. So why aren't we sick all the time? Most of the time we stay well, because the body has a number of ways of fighting germs. Using animation and photography through the microscope, we can observe some of the ways the body defends itself against disease. Many germs enter the body through natural openings, such as the mouth and nose. Here they encounter an immediate barrier, a sticky layer of mucus that is kept in constant motion by tiny hair-like structures called cilia. As germs become trapped in this mucus layer, the rhythmic beating of cilia moves them to the back of the throat, where they are swallowed. Farther along in the breathing passages, other cilia sweep germs and foreign substances up and away from the lungs. Germs that are swallowed move down into the stomach, where powerful digestive enzymes and strong acid destroy most of them. Another of the body's barriers to infection is the skin. Human skin appears to be a smooth, even surface until it is viewed with the electron microscope. Here is a section of human skin magnified 100 times. This section of skin is magnified 2,000 times. It reveals a rough, scaly surface upon which large numbers of germs accumulate. Germs that come in contact with our skin rarely penetrate its surface because of many layers of tightly compacted cells. But when the surface of the skin is broken, germs enter the body. Blood flowing into the wound begins to coagulate, trapping germs and localizing the infection. Blood plays a critical role in our immunity to disease. At the wound, specialized cells called phagocytes that travel in the bloodstream immediately begin the process of destroying germs. Here we see phagocytes engulfing living bacteria. Germs that are not trapped or destroyed near a wound may enter the body's circulatory system. In the bloodstream, germs pose a serious threat to all parts of the body. To meet this threat, all of the body's defenses are called into play. As germs circulate in the blood, They move into the body tissues and then into the lymphatic system. Lymph is a fluid that surrounds many of the body's cells. The lymphatic system plays a major role in the body's defense against disease. Within this system are structures called lymph nodes. The lymph nodes help to trap and destroy germs. This occurs in several ways. Some germs are devoured by large phagocytes. Other cells in the lymph nodes, called lymphocytes, recognize invading germs. When they come into contact with a germ, these lymphocytes are activated and begin to divide, forming additional lymphocytes. These newly formed lymphocytes start to manufacture special proteins called antibodies. Antibodies help to destroy germs. Although incredibly small, antibodies can be photographed with an electron microscope. Here we see antibodies magnified more than 450,000 times, revealing their characteristic Y shape. When a germ enters the body, it triggers the production of one particular kind of antibodies. These antibodies fit that type of germ and no other. For example, antibodies that fight typhoid germs will not protect you against pneumonia. The antibodies attach to the cell wall of the germ. This begins a process that leads to the rupture and destruction of the germ. Here we see bacteria to which antibodies have been added. We can't see the antibodies themselves, but we can observe their effect on the germs. Another way in which antibodies combat germs is to bring them together in groups or clumps. These bacteria cause a form of dysentery, more commonly known as diarrhea. When a drop of solution containing antibodies is added to the slide, almost immediately the germs clump together. Clumping makes it easier for phagocytes to locate and consume germs.